Hello! In our last algebra review section, which is section 8.5, I hope you're ready to think about fractions a little bit more deeply than we have so far, and also radicals and rationalizing numerators and denominators. So let's first start with fractions. In order to add or subtract two or more fractions, we absolutely need one thing all the time, no exceptions, and that thing is a common denominator. So we always, 100% of the time, need the denominators to be the same. Need a common denominator. And the way to get a common denominator, so like if you have, or just use some letters here, like A over B plus or minus C over D, where B and D are different things in the denominator, they're not common. One way to get a common denominator, this is a bit of an oversimplification, as you'll see in some examples that we'll work with in a couple minutes, is to multiply the denominators. So if we multiplied this fraction by D in the denominator, then we'd also have to do the same thing to the numerator. So we have to do D over D, because that's just a special version of 1, and so we're not changing what A over B is if we multiply it by D over D. Then we'd have to also change the second fraction, and we could multiply that by B over B, so that when we multiply these here, so this is going to become, D times A, or just A times D over B times D, and then B times C over B times D. And then they do have a common denominator, so we will have be able to add or subtract their numerators together, and then when we do that, the denominator stays the same as the common denominator. Okay, so let's look at, I've got 3 examples here of combining some fractions together by getting a common denominator. Okay, let's first look at 5 over 8x, and that is being added to 11 over 10x squared. Okay, so we need a common denominator between 8x and 10x squared, and the common denominator is really what's called the least common multiple. So it's the, common multiple is something that you get by multiplying something by something else. And we want the lowest one if we can. You can always go overboard and reduce later, but in this case, we need the least common multiple. We want to try to get that. So you can look at the numbers. We have 8 and 10. And to go overboard, we need to multiply 8 and 10 together to give you 80. That is a common multiple, but it's not the least common multiple. So if we take some time now to find the least common multiple, we will save ourselves time later in simplifying. So I think 80 isn't the smallest, it's going to be 40. So both 8 and 10 go into 40. So our LCM is going to have a 40 in it. Then also we look at x and x squared, and the least common multiple of x and x squared will be x squared, right? We don't have to go up to x cubed. Okay, so this is what we want to aim to make our denominators be. Okay, so in the first fraction, right, I want to think about what do I need to multiply by, okay, in the denominator here in order to make it look like 40x squared. And of course that will be, 8 times 5 is 40. And we need an x to get x squared. And if I'm going to do that in the bottom, I also have to do it in the top. That's perfectly mathematically legal thing to do. Then we also have to get a common denominator for the second fraction, or get the denominator here to look like the LCM. So we're going to need to multiply the 10 by a 4 here to get us to the LCM of 40x squared. And then we already have an x squared, so that's it. So we're going to have to do that in the top as well, though. Okay, so then let's see. In the first part here, when we multiply fractions together, That's the easiest thing to do with them. We multiply across the numerators. So 5 times 5x is 25x. We multiply across the denominators. So that's 8x times 5x. That's 40x squared. Good, that's what we wanted, right? That's what we were aiming for. Okay, the second fraction, 11 times 4. That's going to give us 44. Then we have 10x squared times 4. That gives us 40x squared. Good, that's the denominator we were hoping to get, right? So now we have common denominators. We can put these together by adding their numerators, 25x plus 44. That's the new numerator. And then in the denominator, we don't add the denominators, it's the common piece that we made both fractions out of, and so we have the same denominator here, so that'll be over 40x squared. So there we go, we found a single common fraction that represents those two fractions added together. I know I have here simplify. It's again, depending on what you're using something for in math, that will dictate what's simpler. Oftentimes, though, having one fraction is preferable to having two or more, and I think you might agree with that. All right, let's take a few minutes here to add these three fractions together. I guess we're adding 2 and subtracting 1. Okay, so I encourage you to pause this video and try this, see what you get before you go through it with me. Okay, so let's look at the least common multiple of x and x plus 1 and x squared. Okay, if it were just x and x squared, just like in the previous example, right, we would just have x squared as the LCM. So that's going to be part of our LCM, or least common multiple, or lowest common denominator, I guess we could call it LCD. But also here we have x plus 1. And you can only change the denominator of something by multiplying. So in order to get an x plus 1, we can't just like add 1. We can just do like plus 1, plus 1. We'd have to multiply. So we need to actually include a whole entire factor of x plus 1 here. All right, so let's see, we've got 1 over x. We want to think about what do we multiply x by in the bottom there in order to get us to look like x squared times x plus 1. Well, we already have an x to the first, so we just need x to the first. And then, of course, we need an x plus 1, and we have to do that in the numerator as well. So that's what we multiply the first fraction by. Okay, let's see. The second fraction is x over x plus 1. That is going to need the x squared, right? That's what the denominator there is missing from the LCM or the LCD. I guess I should really call these LCDs, least common denominators. Okay, then we have minus 3x squared. Okay, that one, of course, is missing the x plus 1. Now, let's be really careful here. We're multiplying by the entirety of x plus 1, so we should probably include parentheses around the x plus 1 in both the top and the bottom, and we might as well stick them over here in the middle fraction as well. Okay, so our first fraction in the numerator here, we're going to have 1 times x plus 1. The denominator will be x squared times x plus 1. Okay, in our second fraction here, let's multiply these together. So in the top we have x times x squared, so that'll be plus x cubed. In the bottom, we have x plus 1 times x squared. We're just going to write that as x squared times x plus 1. Okay, then in the last part here, we'll multiply across the numerator. That'll be 3 times parentheses x plus 1. And then in the bottom, we have x squared times x plus 1. All right, this is looking pretty good so far. We just need to push these together into a single fraction. So they already have a common denominator, right? When we add them or subtract them, the denominator stays the same. We will just have x times x plus 1, okay, plus x cubed minus 3 times x plus 1, just pushing those numerators together with the appropriate plus and minus where they go. Now this may or may not be fully simplified. In terms of simplifying the denominator, you can always 100% of the time leave the denominator factored. And you always want to try to simplify the numerator. Okay, now in this case, it looks like, I mean, we've got, these kind of tied up here. We've got plus x cubed, we've got minus 3x, 3 times x plus 1. So we want to try to expand everything out and then see if we can collect any like terms together. Okay, so by expanding, what that means is we're going to distribute this x into here and here. We're going to distribute the negative 3 into here and here. Then we're going to collect any like terms. Okay, so we'll have x squared plus x from the first distribution. Then we have plus x cubed. Then we're distributing a negative 3, so we'll have minus 3x minus 3. And there's not too much to do here, except I think I see an x and a minus 3x, and those are like terms. So we can combine those together, okay, just here and here. Everything else will stay the same. Let's just write it in decreasing degree. So we'll have x cubed plus x squared. We've got 1x minus 3x, so that's minus 2x. Then we've got minus 3. And then again, that's all over x squared times x plus 1. Now the final thing to do might see if you can then factor the numerator. There's no GCF. There's 4 terms, but factoring by grouping isn't going to be successful here. So, it's pretty much as factored and simplified as we can get. Okay. Example number 3 is 3x over x squared minus 9 minus 5 over x plus 3. Okay, we're looking for the least common multiple or the least common denominator between x squared minus 3, x squared minus 9 and x plus 3. Now, whenever you're finding the LCD of things like this, or least common multiple, and you have things that are not linear, so here we have a quadratic, it's definitely best if you factor anything that is not linear. So x squared minus 9, remember back from our review on factoring, this is a really fun difference of 2 squares. So x squared minus 9 is going to factor into x plus 3 and x minus 3. Okay, so what that means is, we already have an x plus 3 here and here. So in order to get the denominators to be the same, we just need to take care of this fraction and introduce an x minus 3. Okay, so the LCD will be x plus 3 times x minus 3, or, x squared minus 9. Okay, so what we're going to do is take, the first fraction is already has the LCD. So all we're going to do is take the second fraction, and we're going to multiply it by x minus 3 in parentheses over x minus 3 in parentheses. I'll just stick a parentheses around that x plus 3 in the bottom as well. Okay, now let's see what happens. I think it might be a little bit nicer to have the x squared minus 9. So let's just see, I'm just going to write it like that. So our second fraction here in the bottom, if we just multiply those, we can write that as x squared minus 9. In the numerator, we'll have 5 times parentheses, x minus 3. Alrighty, now we have the common denominator here. So we'll just combine together into a single fraction. And we're going to leave the denominator as it is, but we could probably, in most cases, simplify the numerator. I'm running out of space here, so let me just rearrange a little bit. Let's put that there. Bring this over. Oops. Let's bring this stuff over here. And let's just make a, all right, that's separated now. Okay. So in the numerator, kind of want to distribute this -5 right through the parentheses. So 3x minus 5x, now plus 15. And we do have some like terms. We've got 3x minus 5x. Okay, so it's -2x plus 15 over x squared minus 9. There we go. We've got a single fraction here. And so we accomplished what we set out to accomplish, a single fraction.